Okay guys, the lesson today, we want to be able to use scale and scale factor to find the lengths of scale models and scale drawings. A scale drawing is a proportional two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of an object. The measurements in scale drawings and models are proportional to the measurements of the actual object. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. Right? The key here is that when we write our ratio for scale, the measurement of the model or drawing is your numerator. The actual object will always be in the denominator of that ratio. All right? Let's look at an example here. It says, what's the actual distance between Cadillac and Detroit? All right, well, here's Cadillac, and where's Detroit? Detroit down here. It says, use a centimeter ruler to find the distance on the map between Cadillac and Detroit. Well, if you're measuring with a ruler, you find the distance between the two is about 3.5 centimeters. And then we have to use the scale to write and solve a proportion. Well, here's my scale up here in the top. Let's undo that. Up here in the top right hand corner. So I start with that scale that says that 1 centimeter is the same as 50 miles. All right. And then we want to say, okay, let's see. And then we're also given 3.5 centimeters. So because centimeters are in my numerator here, 3.5 centimeters is going to be in my numerator of the other ratio. We're looking for the actual distance, which will be in the denominator of that other ratio. All right, we cross multiply and divide. 1 times n is going to be n, and 50 times 3.5 is going to be 175, and those units would be miles. 175 miles approximately between Cadillac, Michigan and Detroit, Michigan. Let's look at another example. A graphic artist is creating an advertisement for this cell phone. If she uses a scale of 5 inches is the same as 1 inch, what is the length of the cell phone on the advertisement? All right, so here's my scale. We have 1 inch is the same as 5 inches. Right, but remember, this is the model in the numerator, and then the actual, right, is in the denominator. All right, we want to write a proportion using the scale to be able to find the length of the cell phone on the advertisement. Okay, well, we see that the length of the advertisement is 4 inches. We want to find the actual length of the cell phone. When we cross multiply and divide, 1 times n is going to be n, 5 times 4 is going to be 20, so the length of the actual phone would be 20 inches. Okay? Let's look at another problem. A scooter is 3.5 feet long. Find the length of the scale model of the scooter if the scale is 1 inch is equivalent to 3/4 feet. All right, well, let's write that. Scale factor, 1 inch is the same as 3/4 feet, and I want to find out, we want to know, find the length of the scale of the model, right? Well, the model is going to be in the numerator, right? In the denominator is the actual object, and that's going to be the 3.5 feet. We cross multiply and divide. 3/4 times n is going to be 3/4 n, and then we multiply 3.5 times 1. That's going to be 3.5. When we divide both sides by 3/4, divide by 3/4, divide by 3/4, n is going to be equal to, all right, I'm going to use a calculator for that, and I'm going to do 3.5 divided by 0.75. That's going to be 4 2/3. And those are going to be inches. All right, 4 2/3 inches would be the length of the scale model. Okay, next example. The liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch is 500 kilometers. How thick is the liquid outer core of the model? Well, I start with that scale of 1 inch is 500 kilometers. And we're looking for the liquid outer core. We want to know how thick it is in the model. Right? So that's going to be in the numerator. The model is in the numerator. The actual amounts are in the denominator. So that's 2,300, and those are kilometers. When we cross multiply, 500 times n is going to be 500n. 2,300 times 1 is going to be 2,300. Divide both sides by 500. Divide by 500. They cancel. N is going to be equal to 2,300 divided by 500, and that's going to be 4.6. So those 4.6 are inches, and that will be the length of the model of the liquid outer core. Right, we continue down here. The mantle of the Earth is 2,900 kilometers thick. How thick is the mantle of the model? Well, we're using that same scale factor that we used up here, so that's going to be, or that same scale, that's going to be 1 inch. That's going to be 1 inch is 500 kilometers. And then we have what? N over 2,900. When we cross multiply and divide, we wind up with, what's that, 2,900 divided by 500. We wind up with 5.8. So N is going to be equal to 5.8, and those are inches. All right, a scale can be written without units. So when the units are the same, the scale without units is called the scale factor. So let's try finding some scale factors, which are going to be the scales without units. All right, a scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. All right, so we know 10 inches and 100 feet. We want to find out the scale factor, the scale without units. Well, the scale is 1 inch is 100 feet, or 1 inch is 10 feet. So if we have 1 inch is 10 feet, we know that each one of those feet is 12 inches. So that's going to be 1 inch is the same as 10 times 12. That's 120 inches. All right, now the units are the same. So my scale factor would be 1 to 120 would be my scale factor. If a drawing has a scale of 1 millimeter to 20 centimeters, what's the scale factor of the drawing? So the scale is 1 millimeter is the same as 20 centimeters. Now we know that each one of those centimeters, every centimeter is 10 millimeters. So that's the same as 1 millimeter over 200 millimeters. They're going to cancel out, so my scale factor is going to be 1 over 200. All right, let's do some more with scale factors. Right, a scale written as a ratio without units in simplest form is our scale factor. So let's continue with that. Find the scale factor of a model sailboat if the scale is 1 inch is 6 feet. So we have 1 inch is 6 feet. That's the same as 1 inch is what? 6 times 12. Each one of those feet is 12 inches. So 6 times 12 is 72 inches. Inches cancel. So my scale factor without units would be 1 over 72. Let's try another one. What's the scale factor of a model if the scale is 1 inch is 2 feet? 1 inch is 2 feet. Each one of these feet is 12 inches, so that's going to be the same as 1 inch is 24 inches. They cancel, so my scale factor without units, 1 to 24. All right. Next example, a floor plan for a home is shown at the left where 1/2 inch represents 3 feet of the actual home. What is the actual area of bedroom 1? All right, well first we're going to have to find the length of bedroom 1. Well, here's bedroom 1 in our drawing here, and bedroom 1 is 1 inch by 4 inches. Okay, so let's start with the length. I start with my scale. My scale is going to be 1/2 inch is 3 feet. That's my scale. Now, let's find the length first. The length of bedroom 1 is going to be 1 inch. So we're going to have 1 inch. That's going to be n. We cross multiply and divide. We wind up with n is 6 feet. Right, but that's just the length of bedroom 1. Right, let's find the width. So the width of bedroom 1, we start with our same scale. 1/2 inch is the same as 3 feet. But in the drawing, bedroom 1, the width is going to be 4 inches. So 4 inches is going to be in our numerator, and in our denominator, once again, is going to be n. We cross multiply and divide. N is going to be equal to, let's see, that's going to be what? That's going to be times what? Times 8, so that's going to be 24 feet. Now to find the area, right, because they're asking us to find the actual area of bedroom 1. Area is equal to, right, let me give us some room here. Right, give us a little more room to work with. Area is equal to length times width. So area is going to be equal to L times W. So area is going to be equal to, our length is 12, or 6, I'm sorry. Our width is 24. So 6 times 24, right, our area is going to be equal to, what's that, 6 times, so it's 120, that's 144 square feet for the area. We want to also find the actual area of bedroom 3. Where's bedroom 3 in our drawing? Here's bedroom 3 in our drawing. So let's start with the length of bedroom 3. That's going to be the same as what we had here, but we'll write it out. We start with our same scale factor, 1/2 inch. I'm sorry, our same scale, because right, we have units, so that's 3 feet. That's going to be equal to 1 inch over n. We know that n is going to be equal to 6 feet again. All right, and then let's find our width. So the scale is what? Same, 1/2 inch, 3 feet. But then that's going to be equal to what? Well, bedroom 3 is 3 inches long, so that's going to be 3 inches here. This is going to be over n, so that's going to be, n is equal to 18 feet. Right, to find area, area is going to be equal to L times W. Area is going to be equal to 6 times 18. 6 times 18, area is going to be equal to 108 square feet. All right. Just one last example here. Find the actual perimeter and area. All right. The scale drawing of a computer chip helps you see the individual components on the chip. Part A asks us to find the perimeter and the area of the computer chip in the scale drawing. Okay. So what do we have to do? Well, we're told when measured using a centimeter ruler, the scale drawing of the computer chip has a side length of 4 centimeters. All right, well, we're given this scale here. 1 centimeter is the same as 2 millimeters. All right, remember, this is the drawing, this is the actual. All right, when measured, the scale drawing of the computer chip has a side length of 4 centimeters. So the drawing's in the numerator. We're looking for the actual, the actual side length here. So that's going to be what? Times 4 times 4. N is going to be equal to 8. Those millimeters. But that's just the side length. All right? So if we're looking for the perimeter and the area, all right, so let's do that. The perimeter then is going to be equal to, because it's a square, all of these sides are going to be 8. All right, so the perimeter is going to be equal to 4 times the 8. So the perimeter is going to be equal to 32 millimeters. All right, that's the perimeter. The area, we'll change colors. Area is going to be equal to the length of the side squared, right, because it's the area of a square. So the length of the side is 8. Area is going to be equal to 8 squared. So the area is going to be equal to Area is going to be equal to 64. These are square millimeters. Alright, so those are our examples today. Hopefully that's been helpful, and we'll see you soon.